Hey guys, so if everything goes according to plan, I'll be doing questions 11 to 17. So let's start with the types of discontinuities. The first thing we have jump discontinuity. Jump discontinuity is when the left side limit and the right side limit are not equal. And this is how it looks like in a graph. So when you see this in a graph, you can easily tell it's a jump discontinuity. Now for removable discontinuities, the left side limit and the right side limit are equal, but the function at that point does not exist. So this is how it would look in a graph. There's this empty circle, which means there's no point at that place. And if they give you something like this, and if they say if x is greater than 2 and if x is less than 2, but they never say if x is greater than or equal to 2 or greater than or less than to 2 or x equal to 2. If there's no equal, then it means it doesn't exist at that point. And it doesn't have to be 2, just any point. And that's discontinuities. So in question number 12, they gave you this and they gave you option, you need to pick the right one. So the first thing you need to know is that this can be written as fx equals to, if this whole thing is greater than or equal to 0, then we just keep it as it is. That's how absolute values work. So if x minus 3 is greater than or equal to 0, which means x greater than or equal to 3, then we just keep it as it is. So x minus 3 if x greater than or equal to 3. Now, if this whole thing is less than 0, it means it's negative and it's an absolute value. So the final answer should be positive. And so then we would have to multiply the final answer by -1 to keep it positive. So if this whole thing is less than 0, x minus 3 less than 0, so x is less than 3. If x less than 3, then we have to multiply it by negative. So negative x minus 3, and so the answer, it would become 3 minus x. So 3 minus x. So now that we have this, it would be much easier for us to solve these. The first one they're saying f at 3 exists. So f when x equal to 3 exists. Now here x equal to 3, we would use this formula. So it would be x minus 3, and we would substitute 3. So it would be 3 minus 3, and that would be 0. So it does exist, so that's correct. Limit as x approaches 3 plus, which means it's approaching 3 from the right side, so it's a little bit greater than 3. So we would use this one. So x minus 3, and then we would substitute 3, and we'll also get 0. Now here, so this one is right because it exists. Limit as x approaches 3 minus, which means it's approaching 3 from the left side, which means it's a little bit smaller than 3. So we would use this because this is the condition. So 3 minus x, substitute 3 inside. 3 minus 3, it would be 0. So this one is also true. Now here they're saying limit as x approaches 3 of fx exists. And that would be correct if these two, if the left side limit and the right side limit are equal. And here we found them to be both 0, so both of them are the same. So this does exist, and it's also going to be equal to 0. Now, here they're saying fx is continuous at x equal to 3, and because f3 and the left side limit and the right side limit are all equal to 0, so they're the same, so it is continuous at x equal to 3. Here in number 6, they're saying it's a removable discontinuity at x equal to 3. We just proved that it's continuous at x equal to 3, so it can't be discontinuous. So the correct answers are 1, 2, 3, 4, and 5. Number 3, they said limit as x approaches 3 minus does not exist. So that's wrong. So that would be wrong because it does exist. So the final answer would be 1, 2, 4, 5. Yeah. So in question 13, they give you this, and they give you options and you need to pick which ones are correct. So if you read them, most of them are asking about the continuity at x equal to minus 2. So let's just find if it's continuous at x equal to minus 2, and then that would just make it easier for us then to just stop, solve. So it would be just easier for us to just look at it and then find the correct ones. So for it to be continuous at x equal to minus 2, the left side limit at x equal to minus 2 should be also equal to the right side limit there, and it also needs to be equal to f at minus 2. So the left side limit would be limit as x approaches to minus 2 minus, because the left side of fx, and because it's from the left side, we're a little bit smaller than minus 2, so we're going to use this equation. So it would be 3x, and we substitute minus 2, so 3 minus 2, and that's going to be minus 6. So that's for the left side limit. Now the right side limit, same thing here, as x approaches minus 2 plus, because right side. And now because it's right side limit, we're going to be a little bit greater than minus 2, so we're going to use this equation. So 2x minus 2, and we're going to substitute minus 2 here, so it's going to be 2 minus 2 minus 2, and 2 times 2 is minus 4, minus 2 is going to be minus 6. And now we need to find f at minus 2, and for that it's going to be x is equal to minus 2, so we'll use this because x is greater than or equal to minus 2. We have to use this equation, and that's the same one as the one on top, so it's going to be minus 6. So now that we found all of these to be equal, now we know that it's continuous, the function is continuous at x equal to minus 2. So the first question asks, does f at minus 2 exist? We found it here to be minus 6, so that's correct. That's correct. The second one, it says fx is not continuous at x equal to minus 2 because it says not continuous, we just stop directly and it's wrong. This third one says it's continuous because we just found that it's continuous. The third one says it's continuous at x equal to minus 2 because f minus 2 exists. It is continuous at x equal to minus 2, but it's not because f minus 2 exists. It's because all of these are equal to each other. So that's why we don't consider it to be true. I'll just put this here. Okay. The fourth one says it's not continuous at x equal to minus 2. You just stop. It's wrong. The fifth one says limit as x approaches minus 2 fx exists. Because the left side limit and the right side limit exist and are equal to the same number, then this does exist and it's also equal to minus 6. So this one is correct. The last one is fx is continuous at x equal to minus 2 because f at minus 2 is equal to limit at as x approaches minus 2 of fx. That's true because we found these two to be equal, which is also equal to this limit at the limit as x approaches minus 2. So yeah, this is equal to this, and that's why it's continuous. So the correct answers are 1, 5, and 6. So in question 14, they gave you this, and they're asking for what value of m is the function fx continuous over the set of real numbers. So basically they're asking what value of m will make this function continuous at any point. Now, if you look at this, the only thing that would make the function not continuous is if x is equal to 0, if x is equal to 6. Because if x is equal to 6, it would make the denominator 0, and we can't have that. So that's why we're only going to look at the continuity at x equal to 6. So if it's going to be, they want it to be continuous at every point, and we're going to look at x equal to 6. So if it's continuous at x equal to 6, then its left side limit should be equal to its right side limit, which also should be equal to f at 6. Now, if you look at this thing here, its left side limit, which is approaching x equal to 6, from the left side is getting very close to 6, but it's never at 6. And here it's the same thing, approaching 6 from the right side, but it's never getting to 6. So both of them, they're not at 6, so both of them would use the same equation. So that's why you don't need to put two equations, you can just put them as one, and you put them here. Now, if you're wondering why I put limit as x approaches to 6, it's because usually, well, in reality, we have to put this every time. But usually I don't write it because usually I just substitute because usually we're dealing with something like x squared plus 1, which is a polynomial, and if you just put limit, so like if you just put the limit as x approaches 2, you don't need to rationalize or simplify or factorize, you can just directly substitute it and you would get an answer. You wouldn't get 0 over 0 or denominator over denominator 0. So that's why I don't write limit usually, because you're not going to get over 0, so you can just directly substitute and get the answer. But here, if you substitute x equal to 6 here, you're going to get 0 in the denominator, and we can't have that. So the first thing you would do is you would factorize this. You can write it as x minus 6 times x plus 6, and then this will cancel with this. Oh yeah, by the way, f at 6. So these two, I represented them as this thing. F at 6 would be when x equal to 6, so it would be m. So that's why I put m. So now these two would cancel, and then you'd be left with limit as x approaches 6, x plus 6 equals to m, and then you substitute 6, so 6 plus 6 equals to m, and then m would be 12. And that's the final answer. Okay, so this question is almost the same as the previous question. So they're asking what value of b makes gx continuous over the set of real numbers. So they want the value for b, for which this function is going to be continuous at any point. And so if you look at this, the only problem that we would have, which would make it discontinuous, is if x is equal to 0, because then the denominator here would be equal to 0, and we can't have that. So we're just going to look at the continuity at x equal to 0 because we don't have any problem with any other point. And so now, for it to be continuous at x equal to 0, the left side limit has to be equal to the right side limit, which also has to be equal to g at that point. Now, just for you to be able to do it faster without having to write all that, you can just write limit as x approaches 0 of gx equals to g at 0, because we already know that left side limit and the right side limit are going to use the same formula because we have this thing, the not equal to sign. So now we have limit as x approaches 0 of gx, which is going to be this equation because we're approaching 0, so we're never at 0. So we're using this equation here. So limit as x approaches 0 of sine 12x over 3x, and g at 0 is going to be b. So after this, remember the rule that we took in the beginning, limit as x approaches 0 of sine x over x equals to 1. Now we can do it here, but we need to have this the same as this. In order to make 3x the same as 12x, we need to multiply up and down by 4. So if you multiply up and down by 4, you have 4 sine 12x over 12x, because 4 times 3 is 12. Now limit as x approaches 0 of sine 12x over 12x is going to be 1, so you're going to be left over with 4 equals to b, and that's the value for b. So in question number 16, they give you this function and they're asking how many points of discontinuity does it have. So this kind of looks intimidating in the beginning, but you can easily find 2 points of discontinuity very quickly. The first one is you look at the top one and you need to see what's going to make the denominator 0. If it makes the denominator 0, then the function will be discontinuous at that point because 0 is undefined in the denominator. So we put 2x plus 4 equal to 0 because that's in the denominator, and then you get x equals to minus 2. So this is already 1 point of discontinuity. Now you look at the other one, the second one, and you see what's going to make the denominator 0. So you put x minus 3 equals to 0, and you get x equal to 3. So that's another point of discontinuity. So these two, you can get them very easily. Now for the other one, you would look at this point. You'd see if it's continuous at this point. So if it's continuous at this point, the left side limit, the right side limit, and f at that point should be equal. So if you look at the left side limit, we're approaching 1 from the left side, so we're a little bit smaller than 1. So we're going to use this equation. So we put this here, and we substitute 1 in here, not minus 1, you substitute 1. And you'll get half. Now the right side limit, we're approaching 1 from the right side, so we're a little bit greater than 1, so we're going to use this equation. So you substitute 1 here, and you will get 3. And then f at 1 is going to be 3x over. So f at 1, you use this one because it has the equal sign. So you substitute 1 here, and it's going to be the same answer as the first one. Now, to be honest with you, you don't need to find this. If these two are not equal, it's directly it's discontinuous. But if these two are equal, then you need to find this one and see if it's also equal. So now that we found out it's not continuous at x equals to 1, it's another point of discontinuity. So in total now, we have 3 points of discontinuity, and so the answer will be 3. If they ask how many points of discontinuity are there. Now in question number 17, they give you a graph and they ask you how many points of discontinuities are there. So in order to just do this quickly, you can just look at the graph and see wherever there is a cut. So you would just, so here there's a cut because it's never, the graph is never going to x equal to 1. So this is one cut, so this is 1 point of discontinuity. And here is another cut, so at x equals to 2. And here is another cut at x equals to 3. Now, the final answer is 3 points of discontinuity, so you just put 3 in your answer. But if you want to know the explanation, it's because the limit as x approaches to 1 minus, so from the left side, it's going to be negative infinity. And as x approaches 1 plus from the right side, it's going to be plus infinity. So whenever you have a limit as x approaches, whenever you have a limit and the answer is infinity, it's discontinuous. Here you have a jump discontinuity because as x approaches 2, so the limit as x approaches 2 minus, so from the left side is going to be 0, but as x approaches 2 from 2 plus, so from the right side, is going to be 4. So there are 2 different points, so it's jump discontinuity. Here, as x approaches 3 minus, limit as x approaches 3 minus, so from the left side is going to be whatever is here, and as x approaches 3 plus, from the right side, it's also going to be the same number. But at f equals to 3, there is no point, which means it doesn't exist. So that's a removable discontinuity. And that's it. Thank you. Wait. I think this is called an infinite discontinuity. So this one would be infinite discontinuity, this is jump discontinuity, and this is removable discontinuity. Wow, that's all of them together. Nice. Now, bye. Bye.